Hey you guys, we're going to cut up some metal today in shop, and there's a lot of different ways to cut metal. You can cut metal with a hacksaw, a great tool. Everybody should have one and know how to use it. Cheap, effective, efficient. You can cut metal using a file. We can use a shear to cut sheet metal. We can use a hand shear to cut rod. We can use a torch to cut plate. But today, we're going to use electricity, and we're going to use some saws. We got 3 different tools here for cutting metal, all different types of saws. We have our abrasive cutoff wheel. This is often called just a chop saw. We've got a 14-inch wheel here spinning at, I think it's about 1400 RPM. It's going to grind its way through the metal, produces a lot of sparks, produces a lot of dust. The saw blade itself is kind of flimsy is not the right word because it's really sturdy in one direction, but it can flex, so you don't always get the most accurate cut. This machine is probably about $100. Next in line, we have a horizontal bandsaw. This is using a 24-inch piece of hardened steel with teeth on it. It's made for cutting mild steel. It's really great for pipe and for round shapes. It also can detach from the base, and you could use it in hard to reach access places. Horizontal bandsaw, one of our newest cutting tools here in the shop. And finally, probably the most commonly used, this is called the cold cutting saw. It travels at a lower RPM than the abrasive saw, and it uses a blade, a 62 teeth blade, 66. It's got carbon tips on each one of these blades, a lot harder than the steel it's going through. It's going to produce a straight cut. It produces very little spark. The chips that come off are hot, but the metal itself stays cool. Really efficient tool. This one is about $500 tool, and the blades are about $100 each. So different applications for these different tools. Let's cut up some metal. We got a piece of 2-inch by 1/8-inch angle iron here. It's the L shape. So I'm going to cut some pieces off either side, and we're going to make a little welding table for inside of the welding booth. Keep our piece off the table. Clip our arc ground clamp on the inside of the angle. So I'm thinking 8 inches be a good measurement. I'm going to come 8 inches. When I get to my number 8, I'm going to mark it, not with a single line, but with 2 lines, making a V or an arrow pointing to the 8-inch mark. That's just going to give me, a lot of times if you just do one mark on the metal, when you get to cut it, you don't know if you're on this side of the mark or that side of the mark for your 8-inch mark. Right? And the other thing we really need to think about, I'm going to cut off multiple pieces, but I cannot measure 8, 16, 24, right? Because by the time I get to 24, I'm going to be a 1/4 inch short. When we're using a saw to cut metal, we're removing metal, and that's called the kerf, K-E-R-F, right? So if I have an 1/8 inch wide blade, I'm losing an 1/8 inch each time I cut the metal. So that 8 inches would be 8 inches, but the next one that was measured at 16 would be 7 7/8. So, but to be efficient, I can measure from one side and then the other side, and I can make 2 cuts on the same piece of bar stock or angle stock before making my next measurement. So I got 2 marked at 8, and then take my scribe and mark my line so I have a nice clear line to cut. Let's take it outside and talk about safety before we turn the machine on. All right, we got the cold cutter out. We're ready to cut up a piece of 2" by 1/8" angle iron. So I got my machinist plugged in. I've got my safety guard in place. When it comes to using electric saws to cut metal, it's vital that the metal is clamped securely and does not move during the cutting operation. As this cutting blade is traveling at 1300 RPM, if there's any movement in the metal that we're cutting, we're going to end up breaking the saw blade. And you can see this blade here, we have carbide tip, carbide tip, carbide tip, and then we're missing 5 carbide tips in a row. A piece of metal moved while we were cutting it, broke the blade, stopped the machine, and made a really loud noise. So let's be sure to clamp really well, no matter what cutting tools we're using. So we have some other safety issues to think about here. We have, this is an extremely noisy tool, so we're going to put in ear protection. And this, although I'm wearing glasses that are safety glasses, I'm going to double up and I'm going to wear a face shield. You really should wear a face shield when you're using this tool. I would also recommend or insist that you wear gloves, right? It's going to be small, sharp pieces of metal are going to come off this blade, and we want to protect ourselves. Ear protection, check. Now I've pulled this second table over, and that's to support the metal, the long part of the metal that I'm cutting off. It's not a piece like this, I could just let it drop. However, when I'm cutting a 10-footer, you have to be sure to hold the metal so it doesn't unbalance the machine as you're cutting. Right on the line. Material is securely clamped. The material is supported. Face shield down. Now the tool has a thumb safety and a finger trigger. All of the sparks, or all of the metal filings in this case, are going to come off in this direction. Now the shield is going to protect you. However, you do not want to stand in line with the saw blade. Stand to the left. Let the tool do the cutting. It's not an axe, right? It's a saw. We're going to engage the metal slowly, move through at the cutting speed of the tool, and when we're done, I'm going to let the blade stop before I lift it back up. All right, it's a nice clean cut. It's straight. It is not hot to the touch. It does have a little sharp burr on the edge, so I'm going to grab a file and knock that off. Let's do one more cut with the cold cutter. All right, let's swap this out for the horizontal bandsaw and cut up another 2 8-inch pieces. So we got our horizontal bandsaw set up, and the clamping system is a little bit different in this one. So I have a chain that's going to come over the stock that we're cutting, and then there's this side that has a hook. I'm going to grab onto those little nubs coming off the chain, and then tighten this down to pull my piece down. It's most effective for round stock, but it'll work on this angle iron too. I'm going to get it close and then adjust to my 8 inches. Line it up with my 8. Nice and secure. Face shield down. Another, not quite as straight a cut, has a little sharp burr. There's a little bit of curve to it. Let's cut one more. Nice and secure. Nice straight cut, looking good. One thing I will say is that this is taking a significantly longer amount of time, right? So I think probably the cold cutter is a more ideal saw to use for this material. But we got one more saw to go, so let's go grind our way through with an abrasive cutoff wheel. All right, we're ready to cut our last piece of metal here. We're gonna grind our way through it with an abrasive wheel. We've got a DeWalt 14-inch cutoff wheel. This is gonna look a lot different, right? There are gonna be a lot of sparks, and you can't, this film is not in odorama, but you can really smell the smell of the abrasive wheel as it's ground away. It's not the most appealing. All right, let's get our way through this. Clamp down securely. We're good to go. Standing out of line with the blade. All right, I think we can all agree that that was the slowest cut of the three. It definitely made the most amount of debris. The metal is hot, and it's left this a long, sharp piece of metal. So, not the most ideal cutting tool. However, there is something that this is superior at. When you see a piece of bar that is hex, we know that this is a piece of high carbon steel. It's got significantly more carbon in it than the mild steel we have over here. That carbon is allowing that careful heat treating of a piece of metal like this to become a really hard piece of metal and far, far tougher to move than a piece of mild steel. So when it comes to cutting hardened steel, an abrasive wheel is more effective, not because it goes faster, but because it spares, it's made to grind away, as opposed to the teeth on the carbide blade that are made to cut. This is much harder to cut. So let's just take a sliver off of here. And another thing you'll notice is that the sparks that come off of high carbon steel look a lot different from the sparks that come off the mild steel. We'll probably have longer streamers, a little bit whiter color than the yellow of those. So we're just gonna take a little bit off the end of this because steel is money, but let's cut it up. All right, effectively clamped down, nice and solid. Let's do this. So, and you can see right as it was getting through the end, it doesn't make a straight cut. The cutting disc actually bends a little bit, and you can see there's a little lip. Ooh, and look at that, really hot. Okay, we're gonna make a little welding table out of these guys. So let's take off those sharp edges with a file. We're gonna pop them in the sandblaster, clean them up, and then we're gonna weld them together.